So when we're factoring, the first step is always to look for that common factor and factor it out. That's always your first step. So if I look at this first one, number 1 here, I can see that the coefficient of the first term is just 1, then we have a 7, and then a 12. And there is no number that divides evenly into 1, 7, and 12. Also, our first term has an x squared, our second term has an x, our third term doesn't have an x at all, so I cannot factor an x out either. So I can't factor out a common factor. So now I move on to sort of the more traditional factoring when we have a quadratic trinomial. Typically, we're trying to factor this into the product of two binomials. So really, we're trying to fill in these blanks of what would go here and here, and what would go here and here, so that when we expand this out or multiply it out, we get x squared plus 7x plus 12. And the general strategy has to do with looking at how we could get that 12 using multiplication, and then how addition of those factors could play a role to get that linear coefficient of 7. There's a few ways to do these problems. I like to use that rectangle diagram to kind of help me set up the problem. So if you draw a square rectangle and split it into 4 pieces, the size of the pieces really doesn't matter. If you're someone who has used these diagrams to expand, when we have two binomials, to actually expand it out into the trinomial, you kind of know from experience that usually in this sort of top left spot is where the squared value would go. So I'm going to put my x squared there, and then similarly I'm going to put my constant of 12 down here in the corner. And so now it just becomes the process of figuring out what to write up here and what to write over here, so that when we multiply out the pieces, we're getting answers that are already here in the diagram. So the only things we can multiply really to get x squared are x and x. And so then we start thinking about numbers that would multiply to the 12, because the number that goes up here and the number that goes down here have to together multiply to 12. So you might in your head, or you might actually list out the things that multiply to 12. 1 and 12 multiply to 12, 2 and 6 multiply to 12, and 3 and 4 multiply to 12. And we're also looking for those factors, in this case, to also add up to 7. And 3 and 4 are really the pair that are going to do it. If I end up with a 3, I could put it down here, and a 4 up here, those numbers will certainly multiply to give me the 12 that I want. And if I fill in the rest of the picture, if I do the 4 times the x, I'd get 4x. And if I do the 3 times the x, I get 3x. And together, the 3x and the 4x would combine together to give us that 7x that we're looking for. So the side links now tell us what our factored expression is. It's x plus 3 times x plus 4. The only thing that really could be different here would be the order of the factors. You could have x plus 4 times x plus 3. The nice thing about factoring is you really always know if your factoring is right just by expanding. So if I were to expand this back out, x times x is x squared, x times 4 is 4x, 3 times x is 3x, and the 3x and 4x together would give us the 7x, and then 3 times 4 is 12. So it could take you a few tries. You might mistakenly use the other factor pairs, but then when you check your work, you'd see that you didn't expand to the proper expression. Let's try one more here like that. So let's now look at, let's look at number 2. Remember, the first thing we always want to do is scan the problem to see if there's a common factor that we could factor out. And just at a glance, I can see that all of the coefficients are divisible by 2. So I know I can first factor a 2 out. And then if I look here, we've got an x squared, an x, and then no x. So I can't factor out an x, but factoring out that 2 will make the process then easier. So dividing each term by 2, I get x squared minus 10x and plus 9. So now what I have to still do is try to factor this trinomial, the x squared minus 10x plus 9, into the product of two binomials. And the 2 that I factored out previously is just kind of hanging out in front. You can factor without using a rectangle diagram, but you still do the same thinking. I'm still thinking about what I could multiply together to get the x squared, and that's going to be an x and an x. So then when I'd multiply those first terms together, I would get the x squared. The way I'm going to get the 9, the plus 9, is to multiply these final terms together. And then remember, the 10, the negative 10, comes from a combination of when I multiply these parts together and when I multiply these parts together, kind of what results when we combine the like terms. So I like to think about things that multiply to that constant. 1 and 9 would multiply to that constant, and so would 3 and 3. And just glancing at those factors, 1 and 9 looks more attractive because when we combine 1 and 9, we do get 10. So I'm thinking maybe I'll put my 1 and 9 here into my factoring. Okay. If I do a plus 1 and a plus 9, then when I sort of check my work, I'd get x squared plus 9x plus 1x. That would actually give us a plus 10x. And then a 1 times 9 would give us the positive 9, but we're after a minus 10x. So I'm going to go ahead and change those plus signs to minus signs. I think I'll just kind of write over them here. So let's change that to a minus and change this to a minus. So now when I try and expand this out, I'd get x squared minus 9x minus 1x. Together that's minus 10x. And then a negative 1 times a negative 9 is still a positive 9. And then, of course, if we were to distribute the 2 to all of that, we would get back the original expression. So I have my factored form, 2 times x minus 1 times x minus 9. So when you're factoring, you want to always first look for a common factor and factor it out, and then try and factor the remaining expression by thinking about really what's going to multiply together to give you that constant value, but will also combine correctly to give you that middle or linear value. Try some of the other factoring problems. Go ahead and work on 3, 4, 5, and 6. And then in another video, I'll talk a little bit about how to go after problems like 7 and 8, because they are a little bit more challenging.